Hey guys, my name is Rahul and I am going to solve 3 questions which are given to me. Before solving the question, I'll read it out. Okay. So I am reading the first question. If the population of a town is P in the beginning of any year, then it becomes 3 plus 2P in the beginning of the next year. If the population in the beginning of 2019 is 1000, then the population in the beginning of 2034 will be. Now there are 4 options and we have to select the correct one. So what the question says, in beginning of any year, let's say that is y1, it is p, and then it becomes in the beginning of next year is y2, 3 plus 2p. Okay, so from here we can say that what we can say exactly, the population is getting increased. How? 3 plus 2 times of the previous one. 3 plus 2 times of previous one. Let's say now this is, we can say that the new population is now Q. Then in the next year means next year means after Y2. So let's say that is Y3. Then it will become how much? 3 plus 2 times of the previous one, 2 times of the Q. 2 times of Q. And what is Q? Q is 3 plus 2P. So we can write 3 plus 2 times of 3 plus 2P. Okay? Just solve it, and after solving, 2 3s are 6 plus 3 9 plus 4P. This is the new population in the beginning of Y3. Similarly, we can find the population in the next year, in the beginning of the next year. Let's say the beginning of the next year is Y4. Okay? Then it will become 3 plus 2 times of the previous one. So previous one is what? 9 plus 4p. We can write directly as 2 times of 9 plus 4p. And after solving, what we get here? 2 nines, 2 times 9 means 9 2s are 18 plus 3, 21 plus 2 4. 2 into 4 is 8p. Now observe the parameter. What we have? Let's say this is our record first and this is record second. We have to observe a pattern now. Okay, and accordingly we will solve. What will be general term means if we have to find in any year, let's say the nth year, in the beginning of nth year. Okay, then what will be the pattern? So P 3 plus 2P, 9 plus 4P, 21 plus 8P. If you observe the coefficient of P, if you see the coefficient of P, here this is 1, 2, it is 4, it is 8, means in the power of 2. We can say here, okay, let's say this 8 is what? 2 power 3. Alright, and we are solving for 4th year, means 4 minus 1 is 3, 2 raised to the power. Okay, and also if you see this is what? 21. What we can write? 3 times 7. And what is 7? 7 is 2 power 3 minus 1. What is 7? 7 is 2 power 3 minus 1. Is it? So we can say that if we have to find the population in the beginning of nth year, then we can say for y4 it is 2 power 3. So for yn it will be 2 power n minus 1. Okay, 2 power n minus 1. And what is this? This is the coefficient of p exactly. So multiplied by p. And what is the constant term? Constant term is 3 times what? It was a 7, and what we observed here, it is 2 power 3 minus 1. It was a 2 power 3 here. Here we have 2 power n minus 1. So we can say that here it is 2 power n minus 1 minus 1. Okay, and this is the plus symbol. Alright. So this is the general form. And what they have asked us, population in the beginning of 2034. In the beginning of 2034. So clearly it is that from 2019, if you observe the gaps in the year, means the difference. So 2019 is the first one, 2020 will be second. Okay, see here, 2019 is first year, 2020 is second year, 2021 is third year. Okay, now after 2021, 2022, 2023, likewise we have to go for 2034. Then if you see here, the gap is 1, the difference is 1, and the year is second, and from here the difference is 2 and the term is third. From 2019 to 2034, if you add 15 to 2019, you will get what? 2034. But year will be 16th, more than 1. This will be 16th year. Okay. So what we have to find? We have to find y16. What we have to find? y16. So for y16, from this expression, what we can get? y16 is 3 times multiplied by 2 power n minus 1. So 16 minus 1 is 2 power 15 minus 1 plus 2 power what? N minus 1, 16 minus 1, 15 into P. And what is P? P is 1000 here. So we can write 3, we can multiply it. This will be 3 into 2 power 15 minus 3 plus 2 power 15, and the value of P is 1000. Okay, we are multiplying here. Now, if you take these two terms together, 2 power 15 will be common, and we will have 3 plus 1000, and this minus 3 is remaining one, so minus 3. Now, 3 plus 1000 is 1003. So 1003 here multiplied by 2 power 15 and minus 3. This will be our required answer. Okay, for the first question. Now we have 2 more questions. So now I will read the second question and then solve the second one. But this is the clear image. I think this is the solution now. Okay, now I'll erase it. So if you check for option, this is the option C. Alright, so C option is correct. Now for the next question, I'll erase it and then we'll read the second question and we'll solve it. So according to question 2, I will read. A club has 256 members, of whom 144 can play football, 123 can play tennis, and 132 can play cricket. Moreover, 58 members can play both football and tennis, 25 can play cricket and tennis, while 63 can play both football and cricket. If every member can play at least one game, then the number of members who can play only tennis. That is the question. So let's draw the Venn diagram accordingly. Means there are, the question is based on the Venn diagram. Okay, it is clear from the question. So we have 3 circles. Let's say this circle represents the players of football, and this circle represents for tennis, and this for cricket. Let's say. Now, what is given? Total 256 members. Total how much? 256 members. And for football players, it is given that it is 144. Football is represented by F. How many can play football? 144. And how many can play tennis? It is given that tennis can 123 players, members can play tennis, and then for cricket it is given as 132. Yeah, 132. So here if we add it, we get 4 plus 3 7 plus 2 9, 3 plus 2 5 plus 4 9, there is no carry, and 3. This is 399. Okay, this is more than 256. It means that as this is more than 256, it means that there are some players who can play more than one game, and it is given in the question also. So how many players can play more than one games? The answer will be 399 minus 256. Okay, number of players who can play more than one game. Your answer will be 399 minus 256, and this is how much? 9 minus 6 is 3, 9 minus 4, 9 minus 5 is 4, and 3 minus 2 is 1. This is 143. This is our first record. 143 is the number of members who can play more than one game. Alright. Now, from the question it is given that how many can play football and tennis? The number is football and tennis 58. Okay. And also cricket plus tennis. Cricket plus tennis. How many members can play cricket and tennis? 25. And football plus cricket. And football plus cricket. How many players can play? 62. So these are the numbers. Okay. If we add this 58 plus 25 plus 63, 8 plus 5 plus 3 is 538 plus 8 16, and 6 to 8 plus 5 13, and 1 14. 146. This is the number. Now here we had 143. Okay. Now we are getting 146. What does it mean? It means that there are some person who can play more than 2 games also. More than 2 means there are 3 games total. Football and tennis, cricket and tennis. Like football, tennis and cricket. There are 3 games. And this is the given data for football and tennis, cricket and tennis, football and cricket. But there is no data for the members who can play all 3 games. Okay. So how we will get the answer? From the, as you can observe that 143 is the number for members who can play more than one game, and 146 is the number we are obtaining for the sum of football and tennis, cricket and tennis, football and cricket. So the difference 146 minus 143 will represent the number of the members who can play all the games. So, number of players or members, number of members who can play all 3 games, all 3 games is 146 minus 143, 146 minus 143, and how much is this? There will be 3. So 3 is the number of members who can play all 3 games. So in the diagram, this section represents the members who can play football, tennis and cricket, all games. Now, football and tennis is 58. Okay. Football and tennis is the number of members who can play football and tennis is 58. Football and tennis. 3 plus 55. 3 plus 55 will be 58. So there are 55 members who can play football and tennis both. Only 55 members can play football and tennis, but 58 members can play football and tennis, okay, and in which three can play football, tennis and cricket. Alright, this is the meaning of the expression here. Now, cricket plus tennis is given as 25. Cricket plus tennis, this is cricket and this is tennis. Here it is 3. Let's say 22. 25 minus 3 will be 22. So how many members can play only tennis and cricket? The answer will be 22. Okay, accordingly. Now, for football and cricket, we have 63. So 3 plus 60 will be 63. So the number of members who can play only cricket and football is 60. That is the answer. And also, we are given as how many members can play football? 144, tennis 123, cricket 132. Here for tennis, they have asked for how many players can play only tennis. This is our question part. Now, for this to answer, we know that how many members can play tennis? 123. Okay. And how many we have here? 55 plus 3 plus 22. If we add it, like 55 plus 22 plus 3, what we have? 3 to 5, 5, 10, 0, 5 to 7, 8. 80. And here 123. So 123 minus 80. 123 minus 80. 123 minus 80. And this will be 3 and 4. So 43 is our answer exactly here. Okay. How many players can play tennis? So the answer will be 43. Okay. So this is the answer for asked questions, and we have to, if we observe, okay, we can find for football and cricket also similarly. Now I will proceed for the third question, and before going for third, this is clear picture for the solution. Okay, alright. Now I will erase it and we will proceed for the third question. So our answer is 43. Now the third question. Third question is from arithmetic progression. It is given in the question. So a sequence is given, and while using the concept of arithmetic progression, I will solve that. So what is the third question? Third question states that if A1, A2, likewise A3, A4, I am reading the question first. If A1, A2 and so on are in AP, then we have to find the value of, I am writing it down, 1 upon under root A1 plus under root A2 plus 1 upon under root A2 plus under root A3 plus so on plus 1 upon under root an plus under root an plus 1. So we have to find the value of this expression. Okay. Now what they are saying, that A1, A2 and so on, given that A1, A2 and so on are in AP, If these are in AP, then the common difference is what? A2 minus A1 means difference of two consecutive terms, in which I am writing the next term first and then subtracting the previous term, and this is constant for AP. So A2 minus A1 will be equals to A3 minus A2. Is it similar? Also this will be equal to, as here we have the maximum term is an plus 1. So the previous one will be an. So this value is constant, and let's say that constant is d, which is known as common difference also. Now we have to find the value of this. Okay, if you observe here, if we rationalize this term, okay, means every term, if we rationalize the denominator, we have under root a1 plus under root a2, and if we multiply with the cofactor like under root a2 minus under root a1 upon what we have under root a1 plus under root a2, we can write it like under root a2 plus under root a1, and we are multiplying with the conjugate pair, so under root a2 minus under root a1, we are multiplying with denominator, and also to neutralize this I am writing it in numerator also. Similarly, plus under root a3 minus under root a2 upon under root a3 plus under root a2, and in second bracket we have under root a3 minus under root a2. Similarly, and plus so on, we have under root an plus 1 minus under root a n upon under root a n plus 1. Okay, just see here that if you multiply this is a plus b, a minus b, we can write like a square minus b square from the formula a square minus b square equals to a minus b, a plus b. So directly we can write it here, but let me write plus under root a n. This is in one bracket, and second bracket we are multiplying with under root a n plus 1 minus under root a n. Okay, that is written there. Now here in the next term, this will be equals to, as I said, if you multiply, we will get from the formula of a plus b multiplied by a minus b equals to a square minus b square. We can write the denominator as a2 minus a1, and the numerator will be under root a2 minus under root a1. Similarly, we have under root a3 minus under root a2 upon a3 minus a2, also not equals, it is plus here. So and so on, under root a n plus 1 minus under root a n upon a n plus 1 minus a n. Okay, now as I said here, a2 minus a1 equals to a3 minus a2 equals to a n plus 1 minus a n equals to d, common difference. They are all equal. So here we have equal denominators. Okay, so we can add the numerators directly. What we can write it? In denominator we have d. Okay, in denominator we have d. D is the value of a2 minus a1, a3 minus a2, similarly a n plus 1 minus a n. And in numerator, if we add it, observe that a2 is being cancelled with this. Okay, so this a2 is being cancelled with the last term of the next term. So a3 will also be cancelled out with the last term of the next term. Similarly, its last term also will be cancelled out with the first term of previous one. Okay, here we have plus sign. So what we have, what is remaining now? What is remaining is under root a n plus 1, under root a n plus 1, and here minus under root a1. Now again, if we multiply this with its conjugate, what we can write? Under root a n plus 1 plus under root a1, and to neutralize this, what we will do? We will multiply denominator also, under root an plus 1 plus under root a1. Alright. So here in numerator, I'll just erase this portion. I can solve here also, just erasing this, and we'll solve in this section. So we have a line here for solving for limited space. So from numerator, under root an plus 1 minus under root a1 in one bracket. In second bracket we have under root an plus 1 plus under root a1. So again we can apply the formula of a minus b and a plus b. So we will get in numerator an plus 1 minus a1, and denominator we have under root an plus 1 plus under root a1 multiplied with d. And what is d? This d, what we have supposed, and which is also known as common difference. Now we will use a concept of again the arithmetic progression, as this is in AP. So we are supposed to use the concepts from AP. Now it is an plus 1 and this is the first term a1. We have the difference. Now from the formula of nth term, Tn equals to first term plus n minus 1 into d. N is the number of terms, okay, in AP. What we have an plus 1 means we are finding the n plus 1th term. For that, if we are finding for n plus 1th term, then we can write an plus 1 will be equals to first term is a1 plus n, number of terms is n plus 1, so n plus 1 and we have minus 1, and the common difference is d. Okay, so from here an plus 1, if we take a1 in left hand side, then we can write an plus 1 minus a1 will be equals to, here 1 minus 1 is 0, n into d. Okay, so we can say that the value of d is an plus 1 minus a1 upon n. This is the value of d. Here what we had an plus 1 minus a1. So an plus 1 minus a1 we can write as n into d. So n into d upon under root an plus 1 plus under root a1, and this is being multiplied with d. So from denominator and numerator d is common. We will cancel it out. It will be dividing remaining one. So what we have now, n upon under root an plus 1 plus under root a1. This is our answer. Okay. So yeah, alright. Hope this answered your question. Okay. Thank you.